So now we're going to look at 1.2. And the first part of 1.2 is we're going to learn about literal equations. And literal equations are equations that have more than one variable. Right, so these equations have more than one variable. I have to tell you what variable to solve for. So these are going to be formulas. So we're going to look at some examples of a literal equation to solve. And we'll start off with an easier one. So this is a really easy one to start with here. This is a literal equation. Notice it has more than one variable. Now we're going to be trying to solve for that variable c. And so that means I get the c by itself. So when we solve, we get the variable, usually the x, but in this case it's going to be the c, and we get the c all by itself. So here's our c. Now we want to move all the other variables to the other side. So I'm going to move that a over with subtraction, and that b over with subtraction as well. Why are we using subtraction? Because subtraction is the opposite of addition, and we want to make sure they disappear. What happens on the left-hand side? Well, on the left-hand side, we have p minus a minus b. On the right-hand side, what happens to my a's? Notice that one is positive, one is negative, so they do what? Cancel. The b's cancel, so what are we left with? On the right-hand side, we're left with c. Let's rewrite this. So I'm going to put the c on the left now, because that's normally the way we write them. And what's it going to be equal to? P minus a minus b. So we solve for what variable now? We solve for the variable c. Let's try another one. And the directions are just going to be solve. Okay, let's look at this one. Let's look at P equals 2L plus 2W. And let's solve for the W. So this is what we're looking at. Is a literal equation. We want the W's. I'm going to put a box around the 2W here. And my goal is going to be to get that 2W by itself. So what do we have attached to that 2W? 2L. Okay. Now, how is that 2L attached to the 2W? It's attached to it by addition, right? So what's the opposite of addition? The opposite of addition is subtraction. So let's move that 2L over with subtraction. So then I have P minus 2L equals 2W. Is everyone okay with that? That 2L over with subtraction there. Now, what are we going to do next? Well, what's our goal? Our goal is to get the W by itself. So what's attached to the W? A 2. How is it attached? With multiplication. So what undoes multiplication? Division. So we're going to divide both sides by a 2. What does that then leave me with? That leaves me with P minus 2L over 2 equals, those can cancel, W. Let's rewrite it. So we have the W on the left. So rewriting with the W on the left, we have W equals P minus 2L over 2. You could separate the fractions out, but normally we don't do that. We just leave it the way it is. So you won't need to separate the fractions out. Just leave it as one fraction like that. All right. Let's try another one. So here's another one to look at. Lots of variables, but don't let it intimidate you. What do we always do first? Parentheses, right? Parentheses always are done first. So distribute that 1/2 H3. It's 1/2 H out in front, and then we've got a capital B and a little b, and there's a capital A on the other side. Okay, so we're going to distribute it through. Now, what is that going to leave you with? That's going to leave you with capital A equals 1/2 H capital B plus 1/2 H little b. Is everyone okay with that so far? So all I did was distribute it through. We need to get rid of the halves. Now, how do we do that? Well, to get rid of the 1/2s, we need to multiply everything by a what? A 2. That's going to get rid of all of my fractions. So we'll do that next here. And that now leaves you with 2A equals, those cancel, H capital B plus H little b. Is everyone okay with that so far? So do you see what we're doing there? Now, what variable are we solving for? Little b. So once we're at this step, we've gotten rid of our fractions, we've gotten rid of our parentheses. So we're going to box the variable we want. And so we want that little b. So we're going to put a box around that H little b. We want that blue box to be by itself. So what do we need to now do? We're going to move over the H capital B. That's going to move that over, and that's going to now leave you with 2A minus H capital B equals H little b. Now again, what variable are we solving for? We are solving for that little b. How do we get rid of the H that's out in front? Yep, because always think in terms of opposites. So it's H times little b. So what's the opposite of times or multiplication? Division. So divide both sides by H. And we're going to now rewrite this. I'm going to put the little b on the left, because that's where it belongs. And what does it equal now? 2A minus H capital B over what? Over H here. That is going to be your final finished answer. And once you do a lot of these, they'll become a lot easier. You're just kind of first learning how they're done. So it's going to get a little easier as we do some more. We're going to do several more. And then we'll look at some applications. So let's do one more of these easier ones. And then I'll work out 2 questions from your homework. So on these, I want you to solve for the variable y. And you're going to be doing a lot of this in the later chapters when we graph equations, because this is going to get this in what's called slope-intercept form. When you solve for y, that is slope-intercept form. Not that important right now. We're just learning how to solve for the variable y. So let's begin by moving that 8x over. Now we have a minus 3y equals a minus 8x plus 4. Divide everything by that negative 3 to get rid of that. And let's now rewrite it as y equals. What do we know about a negative over a negative? We have a negative divided by a negative. What does it become? Remember? Positive. So negative and negative makes it a positive 8/3 x. Positive divided by a negative makes it a negative 4/3. So now we have y equals 8/3 x minus 4/3. So we moved the 8x over, and we divided everything by a negative 3, watched our signs, and rewrote it. Now I'm going to work 2 questions for you from your homework. Okay, if you look at your homework here, let's look at the first 4. 1 and 4 are very similar. 2 and 3 are very similar. So I'm going to work out 1 and 2. That's going to show you how to do 3 and 4. So we're now going to look at our homework, and I'm going to do 1 and 2. So we'll work with our first question here, question number 1.
Do you have to write the work on the homework?
No, if you need to, you can attach it at the end. Just make sure when you work out your homework, okay, you can write all over it if you need to. Make sure your answer, though, goes in the answer blank. That way it's easier for me to grade. Now, if you need extra work, like let's say you want to include your scratch paper, just attach it on the end with a staple. Okay, at the end. So if you need extra work, you can always attach it. Some questions may require some work. Some questions may not. Okay, so when you work things out, if you want to attach your work, just attach it at the end. But please make sure I can find your answer in the answer blank. I do give you partial credit on questions, so make sure you attach your scratch paper, your work. That way I can go through and give you partial credit if you missed a question. So we're going to look now at question 1, and this is out of your homework.
But we don't have to attach scratch work or anything like that.
No, not unless you need to. I mean, in some of these you may need work, but like in 1-1, some of those questions, check to see if it's a solution. Well, you don't really need scratch paper for that one, but some of these you may. So if you work it out on scratch paper, just attach it at the end. So we're going to look now at the first question, and these are a little bit more complicated. Now, this question is going to be very, very similar to question number 4. So this is what we're going to be using to help you solve question 4. So I am doing 1. You'll do the same procedure on 4. So this is going to be very similar to question number 4. What I'm first going to do is I'm going to clear out my fraction. I'm going to do that by using cross multiplication. So I put that W over 1, and I'm going to cross multiply. When I cross multiply, y times w just makes it wy. So nothing has changed there. Just multiply here. What about 1? When I multiply 1 by anything, does it change it? Nope. So that's going to be a 4y minus x. This problem is going to require a new technique. It's going to require us to factor. So we've cleared our fraction. Now we take a moment to think about what variable we want to solve for. What variable are we trying to find? We want to find the y. So I'm going to put boxes around both of those. What's our goal? Our goal is to get the y's on the left-hand side. So I'm going to do that by moving that 4y over. By the way, can I put that wy and that 4y, can they be combined together? No, why not? This one has a w, this one does not. So how would I rewrite it? That's going to be wy, right, minus 4y. Those cannot go together because of the y, that w in front. And what does that equal? Minus x. Now, what do we have in common on the left-hand side? Is there a variable that's in common with what I've got underlined there? They both have a y in common, don't they? So now I can take out that y and put it out front, because these have the same y. So I can put the y out in front, and that's going to leave you then with the w minus 4. So when they have the same variable, we can factor it out. One more step and we are done. How do I get rid of the w minus 4? How does that w minus 4 relate to the y? It relates to it by multiplication, because this is all multiplied here. Distribution is multiplication. So how do we undo multiplication? We undo multiplication by what? By division, right? Okay, so we've got the y factored out. We want to get rid of the w minus 4, so we use division, because division is going to undo my multiplication. Now, when I divide by that w minus 4, what's going to happen on the left-hand side? These are the same, so they can cancel out. Those are gone. So what's now left over? Those cancel out, and that leaves you with y equaling. And what does it equal now? It equals minus x over w minus what? 4. That is our final finished answer. Now, how do we know that we are done? Well, we know we are done because we solve for what variable? Y. And that y is by itself on the left. That's how we know we finished it. The variable we want needs to be by itself on the left. Question 2 is very, very similar. We're going to be using the same technique for question 2. And question 2 is going to be like question 3. So again, this is homework 1.2. We're going to look at question 2. This is 4k plus AR equals R minus 5y. And we want to now solve for the variable R. Let me close that door so it's a little bit quieter. Oh, thank you. Okay, now, do we have any parentheses to worry about? Nope. Do we have any fractions to worry about? No. What's our goal? Our goal here is to get all of the R's on the left, everything else on the right. So that is going to be our goal. So let's box our R's here. We have an AR and we have an R. My goal again is to get both these boxes on the left. I am going to begin by moving that R over with subtraction. So that's going to move it over. So move that R over with subtraction. That leaves me then with 4k plus AR minus R equals a minus 5y. So is everyone all right with what I did so far? Now, why did I move that R over? I moved that R over because now look, these are together on the left-hand side. What is not in that blue box on the left-hand side? What does not belong in that box? What needs to be moved over? Okay, the 4K. Why does the 4K need to be moved over? Because does it have an R with it? No. All the R's on the left, everything else on the right. So move that 4K over. That now leaves me with AR minus R equals a minus 5y minus 4k. Now again, what variable are we solving for? R. Are all the R's together on the left-hand side? Yes. I can now factor out an R on the left because they both have an R in common. And that leaves you with an A because that R comes out. And when that R comes out of the second part, it's going to leave you with a minus 1. So I factored out an R. So when that R comes out, you leave that 1, that placeholder. We are almost finished. And this is the most difficult part of this section. The next part is much, much easier. We need to now finish this, so we're going to divide both sides by an A minus 1. And those are going to cancel out here. And that's now going to leave you with R equaling minus 5y minus 4k over A minus 1. And that is your final answer. Now, how do we know that we are done? Well, we know that we are done because we have solved for what variable? R. R is by itself on the left. And that's what we want. Again, this is the hardest part of this section. The next part is much, much easier. For the next part, we are going to be using the formulas from the back cover of your textbook. So in the back cover of your textbook, you're going to see a lot of different formulas, both on the left and the right-hand side. So any formula that we need, we're going to find in the back cover of our textbook. These questions are not difficult. What we do is we figure out what formula we use, we read the question, we find out the numbers, we plug the numbers in, we find the missing part. That is it. So the next questions are very, very easy. So let's work with a few of these. And we're going to start on page 74 with question, how about 39? And I'll put this up on the screen so we can see it. We're going to read it. We're going to find the correct formula. And we're going to apply the formula. So question 39. Nora traveled from Kansas City to Louisville, a distance of 520 miles, in 10 hours. Find her rate in miles per hour. So what do we have here? Well, we have a distance, right? We know how far we're going. So this problem is going to involve our distance formula. So if we go to the back cover of our textbook, and down at the very bottom under other formulas, we're going to apply our distance formula. Very, very simple to do. So we're going to write up our formula. D equals RT. D is the distance. R is the rate of speed. And T is the time. So this is our distance formula. And if you think about driving a car, there are three things that go into driving a car. How many miles you drove the car, how fast you were going, how many miles per hour, and then how long it took you to get there. So these are the three components: rate, time, distance. Now, what do we know? Well, when we read this question, it says Nora traveled a distance of 520. So we know our D is going to be 520. We also know the time. And the time is 10 hours. So that means our time is 10. We'll put the units on at the very end. So don't worry about putting units on until we finish it. Now, which one do we not know? We don't know the rate of speed, do we? So we're now going to plug our values back in. So 520, that's your D, equals, I'm going to put the time first, because I always like to write the number in front of the variable. So I'm going to put the time first, which is 10. And which variable do we not know? R, right? So time we plugged in, that was 10. R is the unknown variable. How do we finish it out? Yep, divide both sides by 10. And that gives us then our R, which is now 52. We need to make sure we label our rate of speed. Now, when we label our rate of speed, it's either in kilometers per hour or miles per hour. So what do we have here? We have miles per hour. So our answer would then be 52 miles per hour. So make sure you label it. And that's going to be our answer there, 52 miles per hour. You can write MPH as well. Doesn't matter how you write it as long as you label it. So this is going to be miles per hour. So very simple. Find the correct formula, plug the value in, work it out. Question 42. Question 42. As of 2017, the lowest temperature ever recorded was minus 41 degrees in South Dakota. Find the corresponding Celsius temperature to the nearest degree. So we're going to have to round to the nearest degree. Let's look back at our textbook. At the very bottom, you will see under other formulas again, the temperature formula. Now there are two temperature formulas, Fahrenheit or Celsius. Which one do we want? What do we want our answer to be in? Let's go back and look. If we look back at our question, it says, find the corresponding Celsius temperature. So that means we want the formula that says C equals, because that's what we're trying to find. We're trying to find our Celsius. So we use this formula. So let's write it up and plug in our values. So our formula that we're going to be using is C equals 5/9 times F minus 32. What do we know from the problem? Well, we know that corresponding Fahrenheit temperature. So that Fahrenheit temperature is F equals now minus 41. So we're going to plug that minus 41 in, because that is the known part. So we know the F part. Okay, so we know that. Now we can work it out. I'm going to do my parentheses first. So what do I have inside of my parentheses? I have 41 and 32. Those go together, and that makes it a minus 73. So just combine those together. Now, how are we going to finish this out? Well, we're going to multiply. So I'm going to make this minus 73 over 1, just like that. Then I'm going to just multiply the numerators together. So multiply across the top the numerators. We have 73 times 5, and it's a negative. So that makes it a minus 365. 9 times 1 is 9. Now we can go ahead, and it says round to the nearest degree. So we can go ahead and use our calculator, and we can work this out. So we'll just take that minus 365, we'll divide it by 9, and that's going to give us a minus 40.55, goes on forever, or a minus 41 degrees Celsius when we round. So we want to round to the nearest degree, and we want to go ahead and round to that minus 41, and that gives us then minus 41 degrees Celsius. Happens to be the same as the Fahrenheit temperature, and I think that's the only one that does that. So most of the time they'll be different, but we converted from Fahrenheit to Celsius using this formula. We'll do one more, and then we'll take a short break. So one more, and then a break. Question 48. Well, let's do 47, because it's like 48, we'll do 47. So we're going to do 47 here, and this again is on page 75. A sheet of standard size copy paper measures 8.5 by 11. If a ream of 500 sheets of this paper has a volume of 187 cubic inches, how thick is this ream? Well, let's draw up a picture. They've got it kind of over to the side, so we're going to redraw this. That way we can figure out what it is. So let's redraw this figure. And this is just a ream of paper. And here it is. Now, what do we know about this paper? We know the paper is 8.5 inches across. We know it's 11 inches long. And we don't know the height, so we're going to call that X. So you can use an H, it doesn't matter. Let's now go to the back cover of our textbook. You can use an X or an H there. Again, doesn't matter. What does it look like? Well, it looks like that, doesn't it? We drew our picture. Our ream of paper looks like that. Now, what are we working with here? We're working with this one. Does it call for the surface area? No. What does the question want you to find or work with? The volume. So our volume is V equals LWH. So there's our formula. Now, when I read this question, what do we know? Well, we know that it measures 8.5 by 11. So my L is going to be the 11, because this is your L here. This is the W, and this is going to be your H. So L is 11. W is the 8.5. H is unknown, so we're going to call that X. So let's see where I got these from. 11, 8.5, and X, unknown. Now, what do we know about the volume? Does it give us a volume in this problem? It does. It says that volume is what? Is 187. Is everyone okay now with where I got that from? That 187, where'd that come from? Just so we know that 187 was right here in the problem. Okay, so it was in the problem, we found that. We now can put everything together. So we've got our formula, we've got our diagram. Let's finish this. Our formula is V equals LWH. So plug in the values. V is 187. L is 11. W is 8.5. And we called our height unknown, so we're going to use an X here. Is everyone okay with where I put the pieces from? So we know L, W, and H, and the V. Plug them in. Now we can finish it. So what are we going to do? We're going to take that 11 times that 8.5. And that gives you 93.5x. Let me multiply. Next, we're going to divide by that 93.5 on both sides. And how far does it say to round? It doesn't, so it's probably going to come out to be a whole number. Let's check it and see. see what we've got here. We've got that 193. I'm sorry, that 93.5 there. So we're going to take the 187, divide that by 93.5, and that comes out to then give you x equals now what? 2. Okay. And what is our answer then? Well, we want to find the height. So then the height is going to be 2 inches. Okay, so the height there would be 2 inches. Make sure you label it at the end. Now let's go ahead, take a short break. Then we'll come back and we'll do some more of these. So let's take a short break and let's try to meet back here at around 10:45. So meet back here at 10:45 and then we'll finish up this section.